So we're getting ready for session 3. As we all know, the breaks are the best part of the conference, so I'm sorry to spoil the fun. But this is going to be great fun as well. This session, no pressure, is the icing on the cake, where we actually circle back to make sense of the really juicy material that we got from the first session and the second session. I thought that the previous panel did a wonderful job in actually teeing up a bunch of issues for session 3 to look at. So for example, this question about how do we communicate results to decision makers fascinated me. I was also really struck by this question about transparency. So how do we actually communicate the results of this work? Another question I think for the next panel will be, how do we deal with the unknown unknowns? That actually came up in session 1 as well. But this question of flexibility and how do we deal with new risks, which in a way is this move from risk assessment, which is mostly the conversation that we're having in Spectrum at the moment, to risk management and ongoing risk management. So to help us do that, we have another illustrious panel. Let me just introduce our keynoter for this one and the moderator, and then we'll have Julius' speech. Then the panel will join him. I will introduce Julie, even though the usual caveat applies to Julie in a setting like this about not needing. Julie's been with the FCC for 38 years, chief of the OET since 26. He's also been in the Policy and Rules Division and chief of the lab. And, it's interesting thinking about risk analysis. I just can't resist. If there is a single point of failure for the success of spectrum policy in the United States, it's this guy. So Julie, don't get up tomorrow. And let me just say a few words about Rob Oldhafer, who will be moderating this panel. He's a VP of Technology Policy at CableLabs. He's a key figure in spectrum policy. I've worked with him, TPRC, IEEE DISPAN, and he's actually been at the FCC and at the White House. And I can't think of anybody better to host this last conversation. But before we do that, Julius Knapp.
Thanks, Pierre. I've been taking notes and names. But seriously, this kind of germinated from discussions we were having in the Technological Advisory Council that we had even brought up with the chairman of the FCC, Chairman Wheeler, and the Associate Administrator of Commerce Department, Larry Strickland, talking about how do we account for risk, for statistics, for probability when we're doing these analyses. Why? As we're packing more and more into the spectrum, and we've got innovations that are looking to try to gain access to the spectrum, more and more of the dialogue has been about interference. Often the debates, and I'll say a little bit more about this, so one side is, well, this is going to interfere, and the other side is it won't interfere, and we get locked in back and forth. And I wonder sometimes whether we fully understand the analysis and what the real world impact is. And so I'll say a little bit about some thoughts on this, but it really is directed at the community. This is not code for we want to overlay more unlicensed on you, or for the federal government users, we're going to put systems at risk. It's really about how do we continue as a nation to grow and let these services be introduced and hopefully not get wrapped around. I thought our process took a while. Sometimes some will say 2 to 4 years, 28. I'm sure we have some proceeding that's around that long. But, that's not the object of this. It's to try to, as a community, better understand these analyses. So, one of the thoughts was passed on to me was, not everybody in the room is a spectrum guru. A lot of you are. So I took one slide to do a 2-minute primer. Talk about compression. So you've seen this very colorful chart on spectrum allocations, and every one of those colors represents a different radio service. Each service is allocated spectrum, a range of frequencies on the airwaves. You don't think about it, says we don't really use radio dials anymore, but for example, probably everybody knows with FM radio, you see some numbers on the screen, they just account for parts of the airwaves that you're tuning to. And often new services or services that are growing need access to more spectrum. And changes in the allocation chart. Sometimes it's just changes in the technical rules, but the chart is very carefully organized to avoid this term harmful interference you heard. There's been debate for years and years because it's a subjective term. And I just took a snippet. This is out of the international definition, which is repeated in the FCC rules. Interference which endangers the function of safety services or seriously degrades, obstructs, or repeatedly interrupts a radio service. And depending on whether you're the service being degraded or obstructed, you may have a different view of how serious of a problem it is. So the interference debates often arise when we're considering allocations for the new service. What is interference? So, when we had analog TV, we had these things called TESO grades. What the heck is a TESO grade? It was a way of evaluating the interference on a television picture. So experts would look at a picture and say, I can see just perceptible interference. There's some noise in the picture, or interference that was objectionable. In other words, to the point where the picture, if it looked something like this, obviously that's harmful because you can't see it anymore. And you could figure out what the criteria for protection is. For voice, people use things like articulation indexes. Could I understand the voice or not? And when we got to the data world, it's things like bit error rate and how much has the data rate slowed. So things were, I thought pretty straightforward. So I'm going to just go over 2 case studies that are so old, I expect many people have no idea what these were. They were the spectrum fights of their time. 1970, for the law students here, this was just a few weeks after the dinosaurs. Big fight. So for mobile radio, the radios that were being used like police and fire and delivery services and so forth, they were crowding out their spectrum, and so the debate was, how can we use the TV bands to have more land mobile service? And so there was an analysis done. The analysis made a whole bunch of assumptions. What's the height of the, what's the TV service area that we're going to protect? What do we assume about the antennas? How much gain does the antenna have for TV reception? Is it on a roof? How high up? What do we want to do about predicting the propagation in between the two? What do we assume about land mobile? So a whole bunch of assumptions were made, and it was put in place. There was more than one commissioner that voted against doing this, and I'm always reminded, be careful what you say, because one commissioner said, I don't really think there's a need for any more mobile spectrum. So yesterday, we just issued a proposal for 3,850 megahertz of spectrum for mobile, beyond what we have already. So, it all worked out, despite all of the debate and so forth. There really weren't significant problems. It provided more access. So let's move on now to 1979. That computer on the front left, believe it or not, was, many of you would recognize it, was a Radio Shack TRS-80. I think I can say that now because they haven't been sold for a long time. They were very noisy. They emitted noise over a broad range of spectrum. And there were a bunch of real interference cases, different kinds. And so the agency said, you know, we had these old rules that talked about general emissions limits, but they're not really suited for the kinds of equipment we have now. So the agency developed a set of emissions limits. And here are the assumptions that were made. There was a wall attenuation of 8 dB was allowed. There was assumed separate. I can tell you not all walls are 8 dB of loss. It's all over the map. It varies by frequency band and so forth. We made assumptions about the TV signal strength that we were going to protect. It was what I would call rough cut justice. And I just come back to one of the points that was made earlier today about, you know, is the payoff here for a more detailed analysis really worth it in the end? Because there were judgments made here, and it worked. Some would say, well, it didn't work, there's more noise and so forth, but when you think about these became the emission standard for electronic equipment to this very day. And I can tell you that these assumptions here probably, you know, aren't really, a lot has changed on the communications side from these old televisions. So just use those as a couple of examples of where things were in the rough cuts and things turned out. Also with the principle that let's try to make sure that the interference, we can't eliminate all interference, but if we can get it down to a point where there's only a handful of cases, we probably got it about right. So let's move on. There's all these hidden factors that come into play in the testing and in the design factors that go into the radio. So usually when the analyses are done with transmitters, they're based on the maximum power transmitted by the device. And I can tell you it was an eye-opener to me. We usually assume somewhere around 200 milliwatts or so for handhelds. And I saw some data not too long ago that, in fact, the radios generally are around 10 milliwatts or so. So one of the things that happens is the power levels of the transmitters. We do the analysis at the maximum, and the transmitters, for the most part, aren't operating at the maximum. Why? Because you don't want to have a great phone that works for 10 minutes. You know, you're going to preserve battery life. Body loss. We've decided that whether you can use a device is going to depend on how much body loss you have. That's a joke. But we argue back and forth about, well, how much do I account for the loss when I hold it in the hand and so forth. The compliance tests for emissions. So I just told you we did these analysis based on the maximize the, you know, what the level is. The way the test is done and what you're looking at there on the right, the device is put on a table. It's rotated to get the maximum signal. Then we take an antenna and we elevate it up and down to get the maximum combination of the ground reflected and the direct ray. I can tell you when you're out in the field, nobody is trying to create interference by moving the device. There was, you can tell I've been at this a long time, almost heresy about those early computer systems, because what we did is we took, because the wires were radiating elements, and so we moved all the things around on the table to make sure that you got the maximum, because that could happen. Well, we got to a point we said, well, you know, let's just do a standardized layout. We know nobody uses a standardized layout. Oh, no, because that we might not get the maximum. It was fine. So, you know, sometimes there are things that are in the test methods that you don't take account for in the analysis that really help to reduce the occurrence of actual interference. When we do spurious or out-of-band emissions, we assume that there's emissions everywhere, but usually there aren't. They're usually in a handful of spots. The devices have a self-interest often in trying to reduce their level of emissions because they don't want to interfere with themselves. And then we have a lot of debate about aggregates. How do I account for, well, you're doing a test with one device, but there could be 50 devices, or a city's got how many thousand? Let's make assumptions about how many are active at any time and how we add them up and so forth. So there's been a lot of debate lately, and it's a key element in analysis for gaining access to spectrum about aggregates. So let's move on. Notable interference debates. I mean, we could spend probably an hour and a half on this slide. And for some folks, like, this is, yeah, I see some of you, oh my God, don't pull the scab off. Originally I was going to title this Battlefield Spectrum. But just at a high level, how these debates took shape and how interference played such a key role and why they're important. So I'll just start with TV white space. A lot of back and forth about, well, what's the risk of interference to TV or not? And on the other side, and this comes into play, well, if we set the power level so low, there's no market. I'm protected, but there's no service. And so you're constantly trying to deal with, this issue of, have we, and I'll say this at the end, have we overprotected or underprotected? Ultra wideband. My therapy sessions for this finally did the trick. But here's what we proposed. We said, well, let's have a emissions limit that's the same as the limit we had for that noisy computer that I said. And people said, no. We couldn't help it because that was unintentional. We can't allow deliberate noise generators everywhere. And we did these analyses about ground penetrating radars. They'd been around for 30 years. What these things are, they look like lawnmowers. You run them across the ground, and you've probably seen them on the investigative shows, the crime scene shows, where you're looking for something buried. You run them across the ground. Well, they never bothered anybody, at least that we had reported. And but when you did the analysis, they killed GPS and just about everything else in their area. So, we adopted rules that let them go on, and they still are being used, and as near as I can tell, they haven't bothered a soul. I'm not going to go through each one of these. North Point I thought was kind of interesting because there the argument was about interference from the whole idea of North Point was the direct broadcasting satellite service. Generally the antennas were aimed south, so we'll aim our signals north. And the two won't interfere. Well, it was a horrible debate. And it all centered on outages, due to rain, and how many minutes a year there would be outages, and whether it was going to increase it. And if you're a service provider, and fully respect this, you're trying to make your service be as good as it possibly can, particularly when you're competing with, for example, cable. And so there was, the debate there was, well, what constitutes interference, particularly if the variation in the outages from year to year is greater than the difference you're talking about. So anyway, I'll stop there, but what it really illustrates is just how many of these cases hinged on the debates about interference. Generally, the interference analysis were based on worst case. I mentioned usually we do them with the interferer at maximum power, the protected device is receiving a very weak signal. Then we debate about what's a reasonable separation distance. Is it 1 meter? Is it 2 meters? Is it 3 meters? And then in some cases, there are statistical elements. Propagation models by their nature tend to be statistical. We argue about whether to apply clutter or not, how to apply Monte Carlo analyses. What assumptions do we make about activity factors? And the parties often describe the risks in extremes. And I'm not dismissive of the points, but it'll be something like, well, public safety could lose its reception, or lost TV reception, and if there's an emergency, people won't get their alerts, or a tornado's coming and so forth. Or that somebody's trying to make a call and it's a drop 911 call. Or we've lost satellite service, or there's a dramatic degradation in performance. And I'll just take a minute here to talk about, came up before, about the engineers and the lawyers and the policymakers and so forth. I'd just say it a little bit different. First of all, for anybody who thinks that the engineers sit down and all come up with the same answer, you haven't been in a room full of engineers. And the engineers in some ways are worse because the lawyers are used to debating. They understand there's gray. Engineers are trained to work the problem and there's a solution. There's one solution. So there's a lot of passion between the engineers about, the analysis and whether there's a problem or not. And I think what the policymakers struggle with is when, it's not. If folks could come and say, yes, there's interference, or no, there's not interference, it would be simple. But instead, these analyses are usually gray. And when they hear things like this, when a policymaker is faced with folks telling them that somebody could have their 911 call drop, or TV reception could go down in a tornado, it's a really hard thing for them to gauge what to make of all of the information that's put in front of them. Yes, they rely on the staff, but they listen to the participants too. So I would argue that today's systems are a lot more complicated than those simple case studies that I put up at the start. Here's why. Analog versus digital today. With analog, I talked about the noisy picture, and I talked about garbled voice. With digital, we have the cliff effect. Everything looks great until I get to a point where I pixelate and drop off. Then we debate bit error rate and what it means. And the systems are dynamic. They have built-in interference coping mechanisms. They adjust the modulation and the data rates on the fly, because they know that the world out there is not pure and that they're built to work with some radio noise. They often, when the noise degrades, switch to a better resource. So it becomes a matter of how do you evaluate these things and the consequences if there's interference. There's more variables today. We made an assumption about separation between the TV and the computer. Now, could be 1 meter apart or less. But if you set the protection distances at that distance, it may be nobody can build equipment that's going to meet the standard. So where do you draw those lines? The antennas. I put up a Yagi antenna. Well, the antennas now are using MIMO and steered beams. So how do we account for the directionality of the antennas and how they move on the fly? There's the issue of the aggregation I talked about, and one of the things that's been coming up has been, well, I only want to give you 50% of my interference budget because there's other noise sources out there. So we have debate about that. So it's really difficult. The thing I have there on the right-hand side, I know nobody can read it, but it's one page from an application for certification of a mobile radio. And mobile radios, where we went from analog cellular in the early generations, they were pretty limited in the technology they used. Now the radios have got all sorts of modulation techniques, all sorts of bandwidths, all sorts of power levels that they'll adjust to. So it just adds to the whole complexity of the analysis. So way forward, and I think this is somewhat consistent with what some folks said earlier. So the statistics are beginning to enter into analysis. There's still work needed to obtain the underlying data. And I'm not completely sure that this is all easily obtained. But we did debate about the signal levels we're trying to protect. And we don't really know how often is the device receiving the weakest signal. What's the distribution of the transmitted power levels? We're assuming everything's maximum. How often is that the case? How do we treat aggregation? There's a whole bunch of other factors. We really need to develop better statistical models, and I would agree, change is not going to happen overnight. And trying to pick some easier things is probably a smart thing to do. On risk assessment is need to better understand the baseline performance of systems. In other words, it's pretty rare that any system is working 100% of the time, all the time. I probably will hear that from the broadcast community. But, so what is it when we're talking about, well, something may drop? Well, does that happen anyway? Federal agencies, you heard before, have been conducting risk assessments, including relative to safety. And there's two things that were an eye-opener to me, and I'm sorry to go on so long. One, we already talked about the Nuclear Regulatory Commission, and I went over there, and I was just surprised that the extent that they actually do risk assessments. And the other was I had the privilege of sitting on the FAA's Aviation Rulemaking Committee for the devices, allowing devices to be used on aircraft. And, for years, folks had said, well, that cell phone's going to bring down the plane. Or that Wi-Fi device is going to disrupt all the electronics. And we had a terrific group of folks who went through everything, really couldn't, and then FAA conducted a risk analysis. And, it looks like it was a pretty wise decision. There haven't really been any incidents. But for many years it was, there was an incident 12 years ago that nobody could explain, and we just know it was radio interference. So it is being used in other areas, and then assessing the risks of harms against the benefits of creating new opportunities. So why does this matter? Because in talking to folks, increasingly I see people come and say, I've now been on both sides of this. I've been on the side where I'm protecting my service, and I've been on the side where I'm trying to gain access. And I understand that we need to have some sort of balance as we look at things, that we can't go to extremes all the time. So I'll just stop there. I'd be happy to take questions a little later on. Thanks.
Hello, hello.
All right, well, thanks a lot, Julie. That was great. Hi, everyone. My name is Rob Alderfer. I'm with CableLabs, as Pierre mentioned. And Julie, I want to come back to you in a moment, but first, just by way of introduction to the panel here, I'll forego detailed bios, as is the tradition with Silicon Flatirons, just to say that we basically have a panel full of spectrum gurus, which is great. Next to me is Bob Weller, NAB's spectrum guru for the broadcasters. Peter Tenhula, who's the spectrum guru, or at least one of a couple, at NTIA, which is part of the Department of Commerce, who has responsibility for managing the federal use of the spectrum, federal agency use, which is a not insignificant portion of the use, depending on who you ask. Somewhere between 15 and 2/3.
We'll talk about that.
Total. Next to Peter is Joan Marsh, who is AT&T's spectrum guru, or at least one of a couple. So, Julie, let me come back to you, because this entire conference is based on the notion that spectrum is more primitive in its use of risk assessment and qualitative or quantitative risk analysis than some other disciplines. Just before we, take that as a given, what's your view of that? Do you think the FCC is actually doing this in some respects, and how?
So I think things are evolving a bit, and I'm heartened that the topic should be explored to make sure that as we are doing the analyses, whether they're before us now and we go into the future, that we really do understand what the trade-offs are, because sometimes it makes a difference for whether you're going to get access to spectrum or not, or whether a new service is going to be able to be deployed or not.
Okay. And so what about on your fireworks slide there? Were there any, you mentioned there were a lot of scars coming from those particular instances.
You can ask other panelists questions.
But I am curious to know, were there any instances that came to mind for you where it was actually a pretty good analysis that was done and something to build on?
Well, I think all of the analyses were good. But I'll tell you, as you talk to folks in the community, not that necessarily I expect everybody to come to the same conclusion. You'll hear remarks from folks. Someone will look at that and said, yeah, they made the right decision, and that service couldn't have worked anyway, and they did the right thing, and it never materialized. In other cases, you'll hear folks who were an advocate who will say, they really were overprotective, and that killed our chances for it. And I'm not zeroing in, didn't want to reopen old issues, but I think in so many different ways, whether the debates on access to federal spectrum or protecting incumbents, trying to better understand what the real risks are would be helpful.
So let me put Peter on the spot next, because I think it's commonly understood that the notion of something other than deterministic or worst-case analysis benefits new entrants over incumbents. And depending on what end of the range that I referred to in my opening comments around federal agency use of the spectrum, somewhere between 15 and 2/3 of the useful spectrum for radio, agencies are certainly an incumbent. So Peter, can you just talk about how agencies would view this or have viewed this notion of risk assessment? Are they just fundamentally opposed because they're incumbents, or do they see it in their benefit somehow?
First, I'll shoot down your premise on the question about, one, the federal agencies being only incumbents. They're also new entrants, and I'll give you a couple of examples. And I'll tell you that, and I'll also shoot down the premise that they are the largest incumbent. I think that from an allocation perspective, and at least the beachfront spectrum, it's only 17% exclusive federal, and then 31% non-federal exclusive. But then you look at the rest of the shared bands, that's 52%. You look at the table of allocations, and a lot of that, though, is like, for example, 960 to 1215 megahertz. That's a shared band, and it's allocated to aeronautical navigation, aeronautical mobile, and radio navigation satellite, right? And who's the beneficiaries of those federal systems? Those air traffic control systems, the GPS, the radios, the radars and stuff like that. It's the general public, right? To call that a federal band, is not accurate, and to say that that's a federal band, the federal is an incumbent. But at the same time, those incumbent operations, when you're looking at risk assessment, you've got to look at more than just the interference risks. You got to look at the systematic or the system risks, and Julie mentioned a couple of those, like in the in airplane safety and stuff like that. Because from the federal agency perspective, it's the mission, or the task that's important. It's important that the radio spectrum that they're using, obviously lands the plane safely. It accurately gets the data to accurately forecast the weather. It communicates with the firefighter in the forest that they should get the hell out of there. Those are the things the risks that they need to look at. So you look at the definition of harmful interference that Julie talked about. It's that public safety component. It's that higher level of endangers the functioning of the service. And you also have to look at, okay, then how does that affect the mission of the agency? So my answer originally to the question of Rob, is that federal users' interest in risk-informed spectrum policy decisions? Yes, was originally my answer. I thought because maybe it would help, prove that they're right. If you looked at all those layers of risk, and if you quantified all those risks, and you say, yeah, you're right, we need to give you a higher degree of protection under the definition, and here's what it is, and you quantify it. So that's what. But then now have learned today how long it takes, and maybe and the mischief that can be brought into it. Maybe I'm not sure, and I've changed my answer. But let me also point out, and I'll stop. Is that the feds are new entrants as well, and Susan mentioned the Heidi game. Our equivalent of the Heidi game is garage door openers, and I hear it every day, every week. And one of my roles is I chair the Interdepartment Radio Advisory Committee, which is made up of agencies, and I don't think a week goes by we don't hear about garage door openers. I'm not going to tell you the whole story about garage door openers, but in that case, the incumbent were the garage door openers, and they had no rights under the unlicensed Part 15 rules. It didn't stop them from going to the Hill and claiming they had rights to be protected from the interference of the new land mobile radio systems that the military bases were starting to deploy around the country. So every time the military would start to deploy these systems, the garage doors would go nuts around in the town. So the garage door industry went to Capitol Hill, raised a whole fuss, and in the end, the feds won out. But because the rights were defined for the garage door openers in a way that was clear, but the dispute still arose, and it took quite a while to resolve. And there's other instances too, and of the feds being a new entrant, and it's not just the feds here. Like, ever hear of these things called unmanned aerial vehicles or drones? That's a huge interest in the federal sector, and Department of Homeland Security, Border Patrol, military training, and they're having really hard times finding spectrum, and this is also for the command and control, the piloting of the aircraft, right? And the FAA cares a lot about that spectrum too, and how safe it is to operate those unmanned aerial vehicles, which are new entrants, and then add into the payload the needs for a downlink from those drones with high definition video at the border. That's another one. Another one is law enforcement surveillance. The evidentiary standards that they need to meet, are high and getting higher when they have to submit video or audio, to court to convict. So those are the kind of things that we're kind of dealing with, and I think some rigor and data is important to have, but at the same time, it's got to look at the whole stack of those steps.
It actually strikes me that federal agencies may be fairly well equipped to incorporate risk assessment into their spectrum decisions as a function of their core mission and the risk assessment that they do there. For example, I imagine the Department of Homeland Security has a process in place to assess the risk of a terror attack. And it'd be interesting to map some of those practices onto the spectrum inputs to their mission. So that, combined with your shred of hope that they might actually be interested in doing that, maybe we can take that as an action.
I applaud you for your imagination.
So,
Yeah, right.
So Joan, AT&T is in an interesting position. Your company is both incumbent in some instances and new entrant in others. You're incumbent in that you've amassed a healthy mobile spectrum portfolio, and you're also a new entrant in that you need more. So can you talk a little bit about how you view this issue? Because it seems to me that a necessary prerequisite to going down this path is an agreement among FCC stakeholders that there is some benefit to going down this road.
Sure. So I think there's enormous benefit to going down this road because I have scars too. I've been in the battles that Julius been in, and I think reflecting on this issue as the panelists made comments today, I thought was just really interesting, and I thought it might be helpful for me to reflect on one scenario where we thought it worked out pretty well, and then one scenario where we thought it didn't work out very well. The one that we thought worked out very well eventually, but again, there was many years of battles before we got there, was the WCS SCARS, which is the Sirius situation. And for you that are not spectrum gurus, the WCS spectrum sits on either side of where Sirius operates. They operate in the middle. And this debate had gone on how long, Julie? Not 28 years, but it sure felt like
it was
didn't it?
the mobile part of it probably 9 years.
9 years. So 9 years, the industry had struggled on this, and the FCC had done some orders, and they were reconsidered. And as a result, nothing was happening. Sirius was obviously operating in the middle. Nothing was happening with the WCS spectrum of material. It was largely staying fallow. We became interested in trying to solve this. And first of all, that says something about incentives, and I think incentives are really important here. And I think the path to the resolution for us relied on three things. Number one, we sat down on a business-to-business basis with Sirius, and we, at the core, agreed to a definition of harmful interference. And that is not trivial. That, as Julie said, could be the source of significant debate within any spectrum issue. But we were able to agree on a definition, and the concern there was we wanted to deploy LTE services, and Sirius's concern was our service would mute their receivers. So when their customers were driving around, they would not get a good satellite experience, would not be able to tune into the stations. So we were able to isolate that, agree on a definition of harmful interference. Based on that, we were able to come to an agreement on a set of rules that would allow us to deploy LTE where we wanted to, while hopefully protecting them. That was not a trivial exercise either. That was difficult. It was very data-driven. It involved intensive testing and looking at various different assumptions, looking in detail about how we would deploy our network, how they deploy their network. So again, not a trivial exercise at all. And then I think also some of the points raised by the panel that just passed was, what do you do after the fact? Doesn't there have to be some sort of enforcement mechanism? The answer is yes, and it's called a coordination of interest. So even after we got this far, and we worked with the FCC so we could get the rules modified appropriately, the parties also have a coordination agreement, which means as we go forward and deploy our systems, we are required to communicate and coordinate with Sirius. So if something happens that's unexpected, there are certain remedies available in terms of either how we deploy our network, tilt our antennas, or do other things, different equipment we can put out there, etc. So you need the whole package to make it happen, and none of those steps are trivial. They're all difficult. I think if you compare that to where things have gone very badly, and AT&T was just more of a spectator on this, but it's one I think people are well familiar with, was the Lightsword situation. I do not believe that there was good communication going on between the parties who were at dispute there. I don't think that there was joint testing, but Julie may correct me on that. It seems to me that there was the battle of interference testing, which is very unsatisfying in the regulatory arena. It does not produce a result that anybody can really deal with in that arena, least of all the 5 commissioners, chairman of 4 commissioners on the 8th floor, that have to try to sort through this. It got enormously politicized. And as soon as you politicize interference, you're lost. I mean, it just does not help to bring in the politics of this, because you're no longer searching for a solution. You are now lawyered up, and you're backed off to different corners, and you're fighting. And that is just, you're just not going to get there. And as a result, we saw unfold what we saw unfold, which I don't think was satisfying ultimately for anyone. Certainly was not satisfying for Lightsword, which ended up in bankruptcy, and still trying to come out to this day. And it was not satisfying, I think, for the country, because there's spectrum there that's not being used. I don't think it was satisfying for the GPS industry. Certainly GPS devices, in their opinion, were protected, but litigation ensued, so they got themselves embroiled in litigation. So, I compare and contrast those two, and I guess we'll get into a little bit more about what the next steps will be, but I certainly agree with Julie. We need to be more data-driven. I think we need more transparency in this conversation, and I think we have to start with some small, concrete steps to try to find a better trajectory. And I'll stop there.
Can I add just one thing? Not a bit, because there was a comment that was made before about, today, folks pick up through social networks a perception of what's going on, and it sometimes takes hold to the point that while all the engineers are trying to work on very complicated things, people latch on to kind of their simple perception of what it is, and sometimes it's really hard to get past all of that. And not only in that instance, I think in some others too, where obviously we don't want to put incumbent systems at risk, and we want to allow the new services to come in, and sometimes these winds up being just headlines.
I agree. And I mean, as Rob said, certainly as an incumbent, we have an enormous investment in spectrum that we wanted to protect. But there is no noise-free RF environment, period. Every time we go out there, we are managing noise. So the question becomes, when does the interference become harmful? Again, not a trivial question, but nobody has a right to expect an interference-free environment. It just doesn't happen. The wireless industry's been dealing with this for a long time. We coordinate. I mean, we are used to coordinating. We are used to coexisting. It's what we have to do. The FCC doesn't mandate technology, so even in something like the 700 megahertz band, we had a neighbor who purchased a license and decided to do a TDD, time division duplexing deployment in that band against an approach that we did that was separate or different in a neighboring band. That's not a good situation. We coordinated and we made it work. So I do believe too that there's this notion of that anybody can be completely protected in an RF environment is wrong as well.
And just to connect the dots for anyone not familiar with the light squared case, that was an issue of adjacent band interference where there was some underutilized satellite spectrum that was proposed to be converted to terrestrial use, upon which time the GPS community raised concerns that their spectrum, which was adjacent, had receivers that were open, essentially could hear signals in that adjacent band, and as a result, effectively quashed the repurposing of that spectrum, and it remains fallow today. So, Bob, we've heard in prior panels that risk assessments can take decades sometimes to do, and that implementation has been spotty at times. What's your view? Do you think it's a good idea? And if so, what are some of the specific, if we are going to make progress and it's going to be in baby steps, what do you think some of the opportunities for that are?
First of all, thank you for inviting me to speak here. I appreciate Silicon Flatirons as giving a voice to this kind of wonky spectrum policy discussion. First of all, I'm enough of a geek that I read the label on the back of this wireless microphone, and I guess I want to reject the notion that broadcasters are opposed to spectrum sharing. And here's a specific example. Every one of us on this panel are using wireless microphones that operate in the UHF television spectrum. And I'd venture to say that the probability of interference to television by us using these microphones inside this building is very low. So not all sharing is bad. That said, risk-informed spectrum sharing is the future of spectrum policy. But it's something to follow on what Joan, where Joan, I think, was headed. It's something that's best enabled by the marketplace. Government's primary role should be to facilitate sharing, not to mandate it. The bedrock of spectrum policy has been licensed exclusive use sharing. There are gazillions of dollars of investment and assets in that model, and the FCC and regulators generally need to be very cautious as it moves to authorize sharing in order to avoid devaluing those assets. So think of your home as a sharing metaphor. Hopefully I can drive this home a little bit. You only use your home, say, from 7 p.m. till 7 a.m. Weekends, maybe you take a couple of weeks, if you're lucky, each year to go on vacation. And there's a homeless problem in this country. Do you really want the government to let people into your house when you're not using it? Or would you rather choose whom to let in and under what conditions? So maybe you want to set up like an Airbnb at your house. And maybe that's a better model for spectrum sharing. So The government's role, I think, needs to be limited for a number of reasons. That's one. Another reason is there are very strong economic incentives for parties, commercial entities, to work together and share, and also government entities for that matter. And those economic incentives are particularly robust in the area of spectrum. We don't want to end up with squatters that refuse to leave, and we don't want to end up, to follow on in my metaphor, with a home that's trashed and not habitable. So that said, I think the best opportunities are likely to be new services, secondary markets to existing services, and existing services that are really well defined and well engineered. So an example might be point-to-point microwave systems. Those are very well engineered with lots of probabilistic analysis behind them to achieve what's commonly called 4 nines or 5 nines, so 99.999% reliability that the circuit will operate over a period of a year. Those are the types of systems that NAB is now, that broadcasters are now working with, for instance, the Defense Department to do sharing at 2 gigahertz. Broadcasters have critical links in that band, but many of them are very well engineered and well defined. So it's a logical starting point because it's pretty straightforward in the absence of a lot of data that I don't think is out there, to analyze the probability of degradation of the broadcaster link, or vice versa, to analyze the probability of degradation of the Army's link or the Marine Corps' link. So we're starting with the simplest cases first, tactical radio relay systems that are deployed by Army, Navy, and Marine Corps, and once we have a mutual comfort level, I think we'll move on to some other types of systems. And that comfort level, I think, is also very important. That comes from a cautious approach. And there's a real danger, I think, if we make a big leap forward and find that our assumptions weren't quite right, we made a mistake, then the result is going to be pushback against further sharing. So I'll stop there.
But I think there are some instances of specific frequency bands today that are not necessarily simple, but where there is a fair amount of risk involved in spectrum sharing, especially within the same band. And I think this is going to be a sort of a growing circumstance where we're not just dealing with services next to each other, but services actually in the same frequency band sharing spectrum. And right now, the FCC is teeing up its incentive auction, and part of the dynamics in the incentive auction where they're repurposing broadcast spectrum to mobile use is that different amounts of spectrum may be repurposed in different markets. So you'll have within the same frequency band broadcasters and mobile users. So does that give you pause as maybe stepping outside of your NAB world for a minute, but you were involved on the FCC side of that as well. So how do you think the FCC got that right or hasn't got it right?
Uh-oh. This is where you start to cough.
Yes, I need to be a little bit careful because some of those ideas were frankly my own when I was still at the FCC. But to put my NAB hat back on, those sharing concepts were developed to be used in very rare circumstances, and there was little or no data in terms of empirical data. There are paper standards and things like that. You can do paper studies till the end of time, and there's really no guarantee that you got it right until the equipment's built and you can do some measurements. But the seed of those sharing ideas between wireless and the TV band, I think, has moved several steps beyond at least what I had in mind, and it's going to be deployed, like it or not. And I'm not sure either the wireless or the broadcasters or the unlicensed community likes it one bit, but it's going to be deployed, like it or not, in a whole lot more geographic areas than, at least than I had thought.
So we'll see.
Rob, can I just comment on that?
Sure. Yeah.
'Cause I am not shy about commenting on this. So this is not a good idea. We certainly don't think it's a good idea.
Get out of the
We
way.
do not think it's a good idea for sharing. We understand why in this situation, which is a very unusual situation, and it involves sort of reallocating broadcast spectrum to the wireless industry, which obviously we fully support. In this situation, the FCC is trying to reserve some flexibility, and I won't go into a long discussion of the incentive auction, but because they don't, quite frankly, know how much broadcast spectrum they're going to have from market to market. And from a wireless industry perspective, we need a band plan that is the same from market to market. We can't implement a band plan if it changes from market to market. So we've always agreed that the FCC should reserve flexibility so it doesn't become a lowest common denominator problem. I think we disagree in the extent to which the FCC has elected to reserve this flexibility, because we know for a fact that a broadcast allocation adjacent to a wireless allocation is bad news. That's been proven, and we know that for a fact. So we're just hopeful that at the end of the day, we don't see this flexibility used extensively.
Sounds like a deterministic view to me, if I've ever heard one. So, Julie, let's take it up a level here and talk about
Up a level in what?
Get out of the gutter.
a little less inside baseball for those that are not
Less
familiar with the
engineering?
different.
Is that
So, I think it's important to keep in mind here when we talk about the topic of the day that we're talking about risk-informed regulation in the spectrum space, not necessarily risk-based. So the outcome of the analysis won't necessarily drive the decision. There will be other factors that come into play: perception, politics, economics, what have you. So, Julie, maybe you can just give us a perspective on how you would see this sort of analysis being used in your conversations with the chairman and commissioners at the FCC. Would they welcome this sort of analysis? How would they put it in the context of their overall decision?
I mean, I wouldn't speak for. I think the whole area is complicated, and I think the comment was made before that I can't see the chairman and commissioner really appreciating or walking in with a bunch of charts and probabilistic. But and I'm going to just come back to one other point too, because I think it really is important for the stakeholders working together to try to come to a meeting of the minds. From my point of view, those have generally worked out as the best solutions. When you get the engineers on each side sitting down, working through the problems. Not all of the problems are solvable, but you can get to a point where the engineers will say, yeah, I know that could happen, but it's probably a pretty small chance. So I think it's just having, and what I was trying to get to before, away from the simple, well, something horrible could happen. I really enjoyed the keynote here. I'm going to go home and pull the covers over my head and never get out of bed. Because the sense is, people can look at this and see, yeah, I can see maybe some 911 call gets dropped. But the flip side saying, well, what are the odds of that, and what are the benefits of the new service that might be introduced? How many lives might be saved by the new service? And I think the more we can try to help them understand, and that we understand as a community what those risks are, the more likely we'll have decisions that are balanced.
So that's helpful. And Peter, let me build on that and ask you, you've been at the FCC. How do you think the staff would view, not necessarily a mandate, but a strong encouragement to do more of this sort of analysis? Would it be viewed as a procedural hurdle, like we heard from the last panel on the Regulatory Flexibility Act, or could it actually be helpful in some regard?
I don't think it should be a mandate. I think I'm agreeing with everybody here on that it's an incremental approach so that we, apply it to the right cases. And I'm a little worried about resource constraints, especially at the commission and expertise. I could say it at NTIA, at least in NTIA in Washington. But with regard to the clamor, I think, for at least some more quantification and less reliance on anecdotal information, evidence-based decision-making, duh. Guess what? Right down the street, walking distance from here is a lab. NTIA's lab is there it's co-located with NIST and NOAA, and we've developed and are developing. In fact, we got the best propagation experts in the world, that have been doing these models. Longley Rice, they work down there with Bob, right? And they don't get much credit. I don't think they really clamor for much credit, but we're building a capability down there to be that honest broker, to be that collector of data, that collector of evidence. Mike Cotton's developing a monitoring system. He's got a pilot right now. That's collecting data in real time, so you can know where and when spectrum is actually being used, instead of saying, relying on a statement by, let's say, a federal agency. Oh, I use it all the time, everywhere. I need it, But really, we know that they're going to, when they need it, where and when they need it, they're going to need it. So that's a core capability to start basically figuring out, both at the FCC and NTIA, is to provide that honest broker service and data collection type of evidence-based. And because when Julie put up his fireworks slide, and I started seeing some of those examples that I lived through at the FCC, I started having a panic attack. But then I saw 3.5 gigahertz. Thank you for putting that on there, because it made me feel a lot better, because Ed Drusella and the folks here in Boulder at ITS were instrumental at shrinking those zones that covered the exclusion zones in the 3.5 gigahertz band from covering about 52% of the population down to just the coastlines, and then working with the commission based on that data and those measurements to come up with a innovative way through a database and then sensing potentially down the road of using the entire band across the entire country. That felt really good, to kind of see that happen just in the last few months, based on the work that they do in collecting this data and providing the FCC this evidence in these tactical reports. And that's what I think we need more of. And to keep the scientists out there and the engineers out there, busy and funded is important, and independent, and so I think that's a key component to this. And we are a resource. We do a lot of the testing in 5 gigahertz already for, to make sure all the devices, unless the Wi-Fi device in 5 gigahertz, are good enough for, the cable companies to use, and that. But then also we go out and we make sure that those that are interfering with radars, the terminal Doppler weather radars, we can find out fix those problems as well. So it's like Julie was talking about. It's before, like we did in the 3.5, and then afterwards, like in 5 gigahertz, and solve those problems.
So I'd like to try to connect the dots a little bit with the prior discussions, and let me look to Paul and Gary in particular on this. I think what you're hearing in part from some of the speakers up here is that there are certain cases in which you would still want to use a deterministic analysis, that the consequences of something going wrong, interference, are so great that we essentially, the only acceptable answer is to minimize that to the greatest extent possible. Contrast that with, let's say, the nuclear world or environmental protection, where you're dealing with real safety issues, and there is still managed to be an answer that's something other than deterministic, right? Because if it was strictly deterministic, we wouldn't have nuclear power. So can you put in context or give us a perspective whether you see some of the arguments in favor of deterministic analysis in the communication space as legitimate or not?
So absolutely. EPA expressly says there's at least a couple situations where deterministic risk assessment is still useful. One is when there is something very valuable at stake, kids, maybe in environmental justice context or other things like that. The second one is the opposite, where a quick screening assessment will tell you there's no problem. It's not even close to a problem. No sense having to do the more in-depth probabilistic assessment. So they specifically have on a chart. These are the two contexts when you don't have to do a probabilistic, even if you're going to do it in many other contexts. So absolutely. I also just want to just sort of correct people had the assumption that EPA's risk assessment is a mess. There's no question they've had huge problems. There's no question there have been the dioxin and the TCA 28 years, but they do thousands of risk assessments every year, thousands. And they need them. I mean, so one of the famous examples of against risk assessment is how we do hazardous air pollutants, where EPA did only 8 risk assessments in 20 years. So Congress mandated get rid of risk assessment, do best maximum available technology. Well, I was involved in a lot of those rulemakings. EPA was not allowed to do risk assessment. They did risk assessments because they were not comfortable making a decision that would affect people's health without having that. And they actually manipulated the MAC process based on the risk assessment. So the risk assessments were critical there, even though legally they weren't allowed to even be relying on them. So the EPA does risk assessments out the wazoo, and they've gotten a lot better at them. The problem was not deterministic versus probabilistic. If anything, they've gotten much better recently as they moved to probabilistic, maybe because it's not so controversial to have to pick one number.
Interesting.
Yeah, I mean, everything, of course, is continual. And, there isn't like a little cluster over here that's all by itself and another one all by itself over here. And then things in the middle are in the middle. There's a continuum.
It's a spectrum.
It's a pill you take every day. But because of that, I mean, it's not black and white. This is obviously a case where you never consider it, or you can't do that. And you need a screening mechanism which allows you, we've talked about, where you go through, and this is on the far to the left or the right, such that doing full-blown risk assessments is not required. But the devil's in the detail, and the surprises are in there too.
Mm-hmm.
Anything based on average values. Anytime you see a regulation that says on average, be very suspicious, because it's the tails that are going to cause the interesting unintended consequences. And so, and once again, I think that thinking probabilistically is always without having to go in and do excruciating detail, but at least think about it in those terms.
Can I react to that? Because I think the probabilistic thing is so interesting, and I think it's something that we struggle with and maybe are missing. Because in our debates, what you usually have is somebody coming in here saying, if you permit this, this is going to be a disaster. So they're out here. And somebody coming in saying, if you permit this, there's never going to be any noise at all. Everything's going to be A-okay. So we have these extreme cases, and both advocates are going to line up their assumptions that support their cases, but we don't have that bell curve in the middle. We don't seem to have any way to assess against those extremes. And that's something that I don't know what the answer is. I tend to think that there's something, and I don't know if the FCC could require this or not, but those two positions should be required to do, I think, some joint testing.
Yeah.
So, and that would force at least the engineers to get in the room, and they're not going to agree to every assumption. But where they disagree, they should be able to, they should have to back it up. We think this separation is appropriate for these reasons, and we think this separation. We would use this clutter model, and we would use this clutter model for these reasons. So at least there's transparency about why what should be an objective engineering discussion is driven to two completely different conclusions.
Nuclear power went through this, how you operate a plant. And up till about 3 Mile Island, it was a disaster. I mean, they're getting 60, 70%, availability. Post then, they started sharing information. Right? They said, look, we really have to operate well. Let's share our models. Let's share some data. And now they're up to over 90%. And it's been this huge evolution change in the whole industry. And it was because, it was the shock from 3 Mile Island that did it. However, they don't share information about construction. And now they have cost overruns of just a couple of $1 billion is not unusual. And so, to share and decide when it's to the benefit of everybody, to have the right models done, have that, that neutral broker in the middle, doing that kind of work, and having that, so that the differences can be determined. Is it the data that we're arguing about, or is it the model? What is it that's causing us to have different opinions?
You're saying we need a 3 Mile Island incident in the spectrum world to drive collaboration.
No,
That's
no, thank
can
you.
Can I comment on that? Because that's exactly right. We don't, in spectrum law, we haven't had our disaster. Last disaster we had was the Titanic. That led finally to Congress adopting or ratifying a treaty from like 1906 or something like that.
1912.
Like, they did it in 1912, and then because of the one aspect of the Titanic, the radio guys, they went to bed. The radios were the best in the world. They're the state-of-the-art radios on the Titanic, but nobody was there to operate them. So they adopted was the Berne Convention, and then passed the Radio Ship Act and the Radio Act of 1912. We haven't had a 3 Mile Island. We haven't had a Titanic since then. So I'm not saying we need a mandate, but it'd be nice to have a disaster. I'm just kidding. to kind of push this a little forward to make it a little more rigorous on a more regular basis, as opposed to what Joan's talking about, or the irregular, and I can't talk about the second one she talked about because that's still ongoing. But, I've seen it is that go around the fireworks, and it is it's a hodgepodge, and it really depends on the parties and their incentives, and one of the things I've been personally been kind of pursuing is some restatement of the law of harmful interference. What is it? Who has the burden? I don't know, and it seems like the best solutions that we come to are the ones where there's a shared burden and there's a coordination agreement, like Bob's talking about. There's an MOU, like it's going to happen in 2025. There's, the parties finally were forced to get together in WCS and DARS. So I think that's kind of the answer there. But until you get to that point, years later, where they finally come together and say, okay, the FCC's not going to help us. We got to come up with a solution ourselves. I don't think we can wait for that anymore. We have to.
That's what nuclear power did.
Yeah.
They funded themselves.
Uh-huh.
We got to solve this. We have to solve this problem.
Right.
And they did it internally.
So that's a pretty good call to action and a good jumping off point for
But I'm not
audience
calling
questions.
for a disaster. Make sure I didn't.
Not disaster, just some action.
Right.
Not going on your flight.
You know what? I don't go in airplane mode. As a principal, I don't forget airplane mode.
Oh.
No, I'm just kidding. I don't.
Can I
Of
just
course I do.
Say one. No. One
Of course
quick
I
thing.
go.
I'd be remiss not to just thank Pierre because this is. We have a technological advisory council. This is one of the things we asked them to look at. We don't have a rulemaking on this that's pending, and we also work with, hand in hand. We have the Commerce Spectrum Management Advisory Committee that advises NTIA and the agencies. So the whole point of this was to tee it up and have a discussion and try to understand, what makes sense going forward. So thank you.
Very good. So should we do questions or student questions, or are we just about time?
Let's see. Let's just have a quick show. So we're going to make an executive decision and keep you away from the reception for a few minutes to do some questions.
First privilege to a student, or should we just go ahead?
I'm not a student. So.
Are there any students?
Yes, Hi, my name is Irina.
If I may make a suggestion, in order to give everybody who has a question a chance to air their questions, we might actually bundle them up. So we'll do 2 questions, responses, and another 2 questions and responses.
I'm a PhD telecom student here. So this is a kind of a destination imagination kind of question. And I think the responses will be interesting because of the mix of private and public interests that we have here. But say this is 1900 and spectrum's largely fallow and you're free of the burden of historical development in this space. How would you change the spectrum allocations to have avoided some of the problems you've encountered in your work throughout your lifetime?
So good question. Let's hold that, go to the next one, and then we'll do some rapid fire responses.
I'm Anne Marie. I practice law here in Boulder. And my question was, in my sense, if you're moving from a worst case scenario type of analysis to a risk assessment analysis, you're kind of opening the door for lawsuits. You're going to cause a lot of confrontation in that situation. And I was just wondering if the panel feels the same way, if that's a valid concern. And I guess if it is, what would you do about it?
All right, so blank slate, what would you do differently, Julie?
I'd put all the low power stuff together. I think some of the things we're heading to flexibility. I think that's worked out terrific in a lot of bands, and letting the technology and the market drive things is really important. I started with the comment about putting the low power and that all sounds well and good. We've got all these incumbencies and sunk cost investments. You can't just pick up the pieces on the chart and move them around. And it's always going to be changing. So I think, in theory, would you love to be able to take everything and reshuffle it and eliminate some of it? Sure. Is that practical? No.
I love both questions because I've been noodling both of those for 20 years. And the first one is, look at the history. What if Herbert Hoover didn't pull his conferences together? What if the cases didn't happen? What if the concern wasn't with monopolies like Marconi and RCA? Because the interference concern was secondary. It was included. But those historical, go back and look at those cases. In fact, then there's actually debate within the political economy academia about really the case. I can't remember the name of the case, but the one that kind of led Herbert Hoover to really get his clout and get the 1927 Act passed. So look at that stuff, and I challenge the students in the room to research that stuff and do the exact same the hypothetical. What if that didn't happen? What if the Titanic didn't sink? Right? Those series of events led to the 1927 Act, and we're coming up to the 100th anniversary of that, and we're still working under that basic premise. I'd say, and the expert at the time, a guy named Judge Davis, he didn't know what the heck he was talking about when he testified, and he admitted it in testimony. I read it. But take a look at that stuff and see if you can figure out what the answer is, because I don't know. But the second question, which is the FCC has exclusive jurisdiction to resolve harmful interference, so there will be no lawsuits. They will be referred to the FCC under the concept of I don't remember what the legal concept is, but lawyers will figure that. So I've articulated that separately. This is not NTIA speaking, but on my own. Maybe other venues would make sense where some of these disputes can be resolved. I know the Booster case started in court and it ended up back at the FCC. I wonder how that would have ended up if it got the litigation happened there. So I challenge students to look at that issue as well. What if the FCC did not have exclusive jurisdiction? Because FDA doesn't, EPA doesn't. There's lawsuits that happen over those issues, right? I don't know of any other area of law where there's exclusive jurisdiction over this risky kind of thing.
Any more?
Quick. As long as there's lawyers, there's going to be lawsuits.
Yeah.
And we've seen that. I mean, people can sue against the decisions the FCC made. The Light Squared case, the one that I mentioned, they ended up in bankruptcy for years, and there was litigation that rolled out of that where Light Squared sued GPS regarding, I don't even know what the basis of the claim was, but the second question, I really don't think that the litigation risk is materially worse if you move to more of a risk assessment and less of a battle of worst case scenarios. I think the first question is really, really interesting. I agree with Julie. The number one thing would be flexibility of use. Because if you have flexibility of use in spectrum, the market can solve a lot of things. But you need to have flexibility of use to create the market for, so the marketplace can find those solutions. And I think probably the second thing is there's so many of the bands are sliced and diced to so many different incumbents. And then requires coordinated movement or coordinated conduct to try to fix the band. So less slicing and dicing. What we know now, broader band is better band. So that's two. Because as Julie said, you can't undo the puzzle once it's done. It's very hard. A lot of investments have been made, and you just can't undo it in a lot of situations.
Quick response to the first question.
Please.
If you look at the allocation chart that Julie put up, Peter mentioned the specific numbers, but there's spectrum that's exclusively federal government, spectrum that's exclusively commercial, and spectrum that's shared. I would eliminate the distinctions, make it all shared, and rather than having two agencies, NTIA and FCC, frankly fighting with each other over certain things, I'd have one.
What are you talking about?
We discuss.
I have one agency manage it all.
That's interesting. Okay. Two more quick questions, and then we'll have to call time.
I would applaud the initial comments that Peter Tenhula made about that there are industries and the general public that benefit from some of the federal spectrum bands. But I think one of the things you need in this risk assessment and in evaluation in general is the fact that not all users know that spectrum has something to do with something they care about. For example, I would imagine many of you flew here to get to this conference on commercial aviation. So what spectrum bands and frequencies were needed for that flight to safely and reliably occur? How do they avoid dangerous weather or navigation? I'll wager few of us know 100% of the bands that are used for all these areas, but if there's interference, I think the general public and the industries that operate and use those aircraft would care. So how do we incorporate their interests into the process?
Okay, next question. Last question.
Okay. Hi, my name is Roger Marks. I'm involved in the IEEE 802 standardization where we do Wi-Fi and other networking standards. And I wanted to ask Julie a question that I asked him in 2001 when I arranged for him to come to an 802 meeting.
I remember that.
You remember that? Great. And the question I had for Julie at the time was the following. We can develop standards that work well in unlicensed bands, and we can develop the etiquette so everybody can share the spectrum. But the standard's not enough for it to work because in order for that to function, everybody's got to follow that etiquette. And so the question was, if we were successful developing standards that had a broad consensus across lots of industries, could you hold out the idea that maybe sometime in the future they become mandatory? Because that might incentivize to try to do that. And Julie, you said, forget it. It's never going to happen. We're technology neutral. And that's not what you're ever going to see from the FCC. So I'd just like to ask you that question again 15 years later and see if your perspective has changed at all.
I think I'm mostly in the same place. And let me explain why. First of all, the standards have evolved. I mean, things emerged that we couldn't have even anticipated back then. I think on the whole, the process, the framework has worked really well. So we've actually had a couple of proceedings along the way where we asked questions about etiquettes. And it's really been kind of a mixed bag. Not to go on too much. Unlicensed PCS, the industry came in and said, let's develop an etiquette. It was sliced into channel bandwidths and time slots and so forth. It didn't go anywhere. I mean, we allowed time for it to grow. It really didn't catch hold. The thing is, in some of these spaces, there's multiple standards, all sharing the same space. And there's a debate at times about coexistence. There's even one going on now. And you know, the difficulty you have, some folks say, well, yeah, we should have a coexistence framework or something. Others, when you look at some of the things that are in there, they don't follow any standard. And so I would never say never, but I think when you look at the benefits of the flexibility that and the ability to transition over time, overall it's worked pretty well.
Any views on the user interest question?
Well, the FCC's mandate is public interest, convenience, and necessity, right? Not the special interest, convenient, and necessity. So the public interest is, always been served, and I would dispute Bob's depiction of NTIA FCC fight. We work together. The fact that there is two things is a longer explanation of why the president was reserved certain authority and the FCC got the rest. But it's starting to blur. There's non-commercial space launches now. How do you deal with that? The UAVs, federal, non-federal, doesn't really. It's both, right? So you got, like Bob talked about, you got the DoD and NAB working together in the electronic news gathering band. So does that, and they're going to work together to make sure that the stations still get the live reports. At the same time, they're going to still figure out how to do the tactical radio relay exercises with the National Guard at the same time. So they're going to work together to do that. That's what it's all about, right? It's kind of the collaboration, and with the public interest in mind. And that's unfortunately, I always, when I come out here, I feel like I can be bolder and bolder, because and Phil stole that.
It's
Phil stole that from
back
me. Right?
home.
Oh, nobody's watching. Are you kidding? It's Friday. No, it's Friday. It's Friday night. They're out partying. But in Washington, you try to create this conflict, right? You only, and you get these buzzwords: federal, non-federal. It's one team. We got a good team, and it's a lot of fun, So come join us.
Pierre?
Good. And in fact, with that endorsement of the Silicon Flatiron's way of doing things from Peter Tenhula, for which I'm very grateful.
TM, bolder and bolder.
Yes. I'd like to thank this panel. I would also like to thank all the previous panels and the speakers and the moderators who did a lot of work behind the scenes. I'd like to thank all of you for being here. I'd like to invite you to join us at the reception. Since we're starting late, we'll keep going a little bit later. Yes, Anna says we can keep going. So you won't lose time for conversation. I'm sure there are more questions and more debate. Yes, thank you very much. So as I mentioned right at the start, it's free, but there is in fact a price. The price is that the students should talk to the practitioners and the practitioners should talk to the students. So will the students raise their hand and everybody else look around and see who you should be talking to? And a good turnout of students. Thank you very much for coming, and I hope you have a wonderful evening. Safe travels home.